Alright, if you have viewed the first video, you have already know what is the meaning of this chemical reaction, this equation here. So in short, for exothermic reaction, enthalpy change is negative. It means that it has actually lost energy to the surrounding. Therefore, the temperature should actually increase. Alright, and for an endothermic reaction, the enthalpy change is positive, which means it has gained energy from the surrounding. So therefore, the temperature of the surrounding should actually drop. But do take note that this is actually just the overall, the enthalpy change. This equation is only valid for the overall reaction. Okay, now what is going to happen next? We are going to learn in the so this is from the macroscopic perspective. What we're going to learn now is the microscopic perspective. Alright, so what causes energy changes in a chemical reaction is actually the breaking of bond and the formations of new bond. Alright, so what happens is that we need to know this. Another chemical equation known as the enthalpy change is equals to the total energy used in bond breaking plus the total amount of energy released in bond forming. Alright, so remember, this is very different from the first equation that we learned about enthalpy change. It's equals to the total energy in product subtract the total energy in reactant. Alright, this is for the overall reaction, and over here what we are looking in is the microscopic level. We are looking in terms of the bonding. Alright, so this is for the overall perspective, alright, overall reaction, and this over here, okay, is actually from the microscopic level, alright, from the atomic level. So for example, I've got a reaction A plus B, alright, gives you A, B, balance equation. I'll have a 2. So just to recap, this is actually your product, and then this over here is actually your reactant. Alright, so what happened? For every reaction to occur, alright, all the reactants will have to gain energy to first break the bond, right, to become individual atom. So for example, if I've got an energy level diagram over here, if I've got an energy level diagram, or energy profile diagram, alright, what will happen is that my reactants, they are here A, and B. Okay, so for a start, they will have to gain energy to break them up into individual atom A and BB atom. And after that, they will mingle around, alright, they will mix around, and upon forming the new compound, they will start to form, and as they form, energy will start to drop, and then they stabilize with and then they'll start to stabilize and form a new product of AB. And that's how reactions are formed. So during the process of gaining energy over here, alright, okay, energy is actually being absorbed. So when energy is being absorbed, this means that this is actually an endothermic reaction, which has a enthalpy change of a positive sign. Alright, so over at this end, over at the product end, in order for them to form energy, energy will needs to be given out. Alright, give out energy. So this must be an exothermic reaction denoted by a negative sign. Alright, so what will happen in order for us to find the total enthalpy change from the microscopic level? I will have to take the total amount of energy, alright, needed for bond breaking plus the total amount, alright, plus the total energy, alright, required for bond forming. And since I know that bond breaking is a positive value, alright, and bond forming energy is given out is a negative value, so therefore I can have the overall chemical equation as total energy of bond breaking, alright, plus the negative of total energy used in bond forming, so release in bond formation. Alright, so take note of that, and that is another way of how I can find the enthalpy change. Alright, now for example, if AA and BB they gain energy at only until this level, alright, the reaction will not proceed. Why is it that the reaction will not proceed? Is because it has not achieved the sufficient amount of energy to break them up into actin. So this minimum amount of energy that's required, alright, for a chemical reaction to take place is known as the activation energy. Alright, this is known as the activation energy. Okay, and then in this chemical energy profile diagram over here, this is the activation energy. Alright, and this over here is the overall enthalpy change. Alright, so if I'm going to make use of the first equations that I've learned, enthalpy change is equals to product total energy of the product subtract the reactant, it is still valid because the overall enthalpy change is still positive. Alright, and if I'm going to make use of these equations that I've learned over here, alright, calculating from the bond to the top, overall net will still be a positive value denoting a endothermic reaction. Alright, I hope this clarifies.